So today we're going to look at writing and solving equations in context. Recall that an equation is a mathematical statement that shows two expressions are equal. So when you have an equation, there is an equal sign, and each side there is an expression. Other vocabulary terms, we have our variable. A variable is a letter that is used to represent an unknown quantity. To the right, you're going to see a simple example of an equation, 3x plus 5 equals 14. In that equation, x is our variable. Next vocabulary word, the coefficient, is a number by which a variable is multiplied. In our example, the 3 is a coefficient. A constant is a term in an expression that does not change value because it does not contain a variable. In our example, there's actually two constants. The 5 and 14 are both considered constants. Let's look now at a scenario. We have Julio has $5 more than Dan. Altogether, Julio and Dan have $19. How much money does each young man have? So we have questions A through E. Starting question A, let D represent the amount of money in dollars that Dan has. Use D to write an expression that represents the amount of money Julio has. So our goal, part A, is to write the expression for Julio using D as our variable that represents the amount of money Dan has. So we're writing about Julio. What do we know about Julio? Julio had $5 more than Dan. So we're going to write an expression to represent that about Julio. Julio had $5 more than Dan. D represents Dan's money. We should write an expression as D plus 5 would represent how much money Julio has. Part B, write an equation. So now we're going to use that equal sign to represent the entire problem situation. So thinking about that second sentence altogether, Julio and Dan have $19. So we have Julio and Dan together have $19, right? Okay, so we just wrote an expression for Julio, and that was D plus 5. I'm going to use parentheses just as grouping symbols. The word and, or in the statement, it talked about altogether they had $19, so we're going to add that with Dan's money, which was already represented by the variable D, is going to equal 19. D plus 5 plus D equals 19 is our equation. Step C, solve your equation showing each step, state a property, or provide an explanation for each step, and then check your solution. So I'm going to use this space to the right to rewrite our equation, and we'll solve it. Here is our equation that we came up with. Now, right now I have parentheses around the expression representing Julio's money. There's not distributive property happening here, so I can actually just drop those parentheses, but I am going to combine like terms. 1D plus another 1D would make 2D plus 5 equals 19. It said to list a property or explain, we just combined like terms. Next, I'm going to subtract 5 from both sides. That is the subtraction property of equality. I'm going to write subtraction and prop just for shorthand there, which would leave me with 2D equals 14. Next, I will divide both sides by 2, which is the division property of equality. Let me write that to the side. And that'll leave us with D equals 7. I'm going to use the space below part C to check our solution. Our original problem was D plus 5 plus D equals 19. If we plug in 7 for D, we have 7 plus 5 plus 7 more. Does that equal 19? Well, sure. 7 plus 7 is 14. Add another 5 is 19. 19 equals 19. It did check out. Part D, interpret your solution within the context of the problem. So we just wrote our equation and we solved and we found D equals 7. Now, remember, what did D stand for? Dan. Dan's money was equal to 7. Now, the problem asked, how much money does each young man have? How much does Julio have? Does Julio have $7? No. Julio had $5 more than Dan. So how much money does Julio have? Remember, the expression we wrote for Julio in part A was D plus 5. So 7 plus 5. Julio has $12. Julio has $12. Dan has 7. And then part E, verify the reasonableness of your solution by checking that your answer matches the information given in the original problem situation at the top, meaning that second sentence where they said all together Dan and Julio had $19 is 12 plus 7, 19. Does this all make sense when we pull it back together between the written context, the equation that we created, and the answer that we got? Absolutely, yes. Julio's $12 and Dan's $7 together is 19. Let's look at our next example. Number 1, members of a softball team raised $1,513.50 to go to a tournament. They rented a bus for $961.50 and budgeted $46 per player for meals. Write and solve an equation that can be used to determine X, the number of players the team can bring on the tournament. So they've already defined a variable for us, X. How many players can we actually take to this tournament? So we're going to a tournament. A couple things that are involved in paying for this tournament. We've got a bus and we've budgeted costs per player for their meals. And we only have so much money that we've raised. In this scenario, we're using all that money that we've raised for the tournament, so it can be exactly equal. Our cost to go to the tournament, including the bus, per player, can be equal to our total number of our amount of money raised, the $1,513.50. Okay. They said the bus was $961.50. We also, I'm going to add, also going to have to pay cost per player for meals. They said that was 46, and I did go ahead and underline that word per. I hope you recognize that as a keyword to remind us that it's going to be multiplied per player. Every player that I take needs $46, so it's going to be multiplying with my variable that they already defined, X, for the number of players. So we're going to have $46 per player, so times X, we're using for number of players, is equal to $1,513.50. There's your equation. Okay, we're going to a tournament. We've only got so much money. We got to pay for a bus, and everybody needs $46. So how many players can we take? So here's your equation. We are to write and now solve our equation. So let's solve this out. Subtract that $961.50 to the other side. We have 46x equals $552 divided by 46. How many players can we take? X equals 12. 12 players can go to the tournament. Let's look at number 2. Lincoln buys milk and oranges at the store. He pays a total of $41.63. He pays a total of $4.19 for milk, and he buys 6 bags of oranges that each cost the same amount of money. Write and solve an equation that could be used to determine X, and they've already defined X is going to be how much each bag of oranges cost. Okay, so Lincoln bought some milk and oranges, bags of oranges, multiple bags of oranges, and it is equal to a total. They told us that total was $41.63. In the second statement up here, 1, 2, 3, the second statement, the milk was $4.19, and he bought oranges. Now, he bought 6 bags. Each bag cost the same amount, which they used for our variable X. 6 bags, each cost X amount of dollars. So we have 6 times X. Here's our equation. Now we are ready to solve. Subtract the $4.19 for the milk. We have 6x equals $37.44. Divide both sides by 6. How much does each bag of oranges cost? $6.24. Each bag of oranges costs $6.24. On the second page, we have one last example, number 3. Parker wants to ride his bicycle for 34 miles this week. He's already ridden 10 miles, and if he rides 5 more days, write and solve an equation, which could be used to determine X, the average number of miles he needs to ride each day to meet that goal. Each day. Okay, so he wants to reach a goal of 34 miles for the week, already ridden 10, plus 5 more days, a certain amount of miles each of those 5 days. You seeing it? All right, so we have already ridden, and we're going to ride some more for 5 days. Needs to equal our goal. That goal being 34 miles total. Already have ridden 10 miles, and I mentioned this earlier, and we are going to ride a certain amount of miles per day, each day, for 5 more days, right? Each day, 5 more days. So 5 times this average that we need to hit to make our final goal. And they already said that X is going to be that average number of miles that we need to ride each day for these remaining 5 days of the week. So that is going to be our variable. 10 plus 5x equals 34 is our equation. So we are ready to solve. Subtract 10 from both sides. 5x equals 24. Divide by 5. X equals 4.8 miles that he needs to ride for the next 5 days to meet his goal. Parker must ride 4.8 miles per day to reach his goal. All right, so that is our lesson on writing and solving equations in context. So some word problems, some scenarios. We started with some vocabulary, variable, coefficient, constant. This comes up a lot in testing questions, like identify the expression, identify the term that has, or the term that would represent, and we're going to practice that more in some future lessons. And we walked through the example with Dan and Julio, kind of practicing writing an expression versus an equation, and using those defined variables to solve an equation. I gave you 1, 2, and 3 there on the notes because they are directly from Delta Math, so you may see some that are very similar. Hopefully I grabbed enough examples to model for you there. If you have questions, be sure to ask me in class or let me know. Be glad to help you. I'll see y'all later, okay? Have a good day.